Assalamu alaikum. This video is about intercepts of the graphs of a function. What is a solution point? An ordered pair x of 1, y of 1 is a solution point of an equation in x and y when the substitution x equal to x1 and y equals to y1 result in a true statement. An ordered pair x of 1, y of 1 lies on the graph of equation in x and y if x of 1 and comma y of 1 is a solution point of the equation. When does point lie on the graph of y is equal to fx? A point x of 1 comma y of 1 lies on the graph of the equation if x of 1 comma y of 1 is a solution point of the equation. Example 1. Determine whether 3, 0 lie on the graph of y equals to x squared minus 5x plus 6. So let's write down the equation y equals to x squared minus 5x plus 6, and let's substitute x equal to 3 and y equal to 0 from this point 3, 0. So this equation becomes y becomes 0, x squared becomes 3 squared and minus 5 times 3 plus 6. So let's simplify each side. One last side is 0. 3 squared is 9, 5 times is 15 plus 6. So 9 minus 15 is minus 6 plus 6 is 0. So it looks like we have 0 equal to 0. This is true. So we can see as point 3, 0 does lie on the graph of y equal to x squared minus 5x plus 6. Because 3, 0 is a solution point of the equation y equals to x squared minus 5x plus 6. So here is an example 2. Determine whether minus 3, 27 lies on the graph of y equals to x squared minus 5x plus 6. So let's write down the given equation y equals to x squared minus 5x plus 6 and substitute x equal to minus 3, y equal to 27 from the given point negative 3, 27. So y becomes 27 and x will become negative 3 squared and then minus 5 times 3, negative 3 and plus 6. So let's simplify each side. The left side we have 27. Negative 3 squared become positive 9. When you square a negative number, it should become what? Positive 9. Now negative 5 times negative 3 is a negative times negative become positive also 15 and plus 6. So now 9 plus 15 becomes 24 plus 6, 30. Now it says 27 equals 30, which is not true, false. So we'll say no, negative 3, 27 does not lie on the graph of this equation y equal to x squared minus 5x plus 6 because minus 3, 27 is not a solution point of the equation. So what are the intercepts of the graph in a given plane? In a plane, there are two types of intercepts. X-intercepts. And what is x-intercept? Well, x-intercept is a point on the x-axis where the graph of an equation crosses the x-axis. And y-intercept? Y-intercept is a point on the y-axis where the graph of an equation crosses y-axis. So here is example 3. Identify the x and y-intercepts on this given graph. X-intercepts, points B and C on the x-axis where the parabola crosses x-axis. So this point B and this point is C. Here the graph crosses x-axis. So these are x-intercepts. And the coordinates of this point is negative 3, 0. And the coordinates of this point 3, 0. So these are x-intercepts. Y-intercept is a point A, this A is a y-intercept because the parabola crosses y-axis at A. And its coordinates are 0, 9. Next, how to find the x-intercepts of graph of an equation. So to find the x-intercepts of graph of an equation, you just let y equal to 0 in the given equation and then solve the equation for x. So here is an example 4. So we're going to find x-intercepts. 3x plus 4y equals to 12. So let's write down the equation 3x plus 4y equals 12. Now we substitute y equals 0. So this equation becomes 3x plus 4 times 0 equals to 12. 4 times 0 is 0, so we're left with 3x equals to 12. So to isolate x, we divide by 3, so 3x over 3 equals to 12 over 3, so it becomes x equals to 4. So the x-intercept is 4, x is 4 and y is what? 0. How to find y-intercepts of the graph or equation? Well, to find the y-intercepts, you let x equal to 0 in the given equation and then solve the equation for y. So let's find the y-intercept, 3x plus 4y equals 12. So let's write down the equation 3x plus 4y equals 12 and substitute x equal to 0. So the equation becomes 3 times 0 plus 4y equals 12. 3 times 0 is 0, so it's gone. So we're left with 4y equals 12. Now we divide by 4. So 4 over y over 4. 4 cancel gives you y. 12 over 4 becomes 3. So y equals 3. The y-intercept is 0, 3. Example 6. Finding x-intercepts of the graph. So here if we have an equation square root of y equals square root of 2x plus 3. So again, let's write down the equation. And since we want to find x-intercept, we're going to let y equal 0. So the y becomes 0. So we have 0 equal to square root of 2x plus 3. Now we have to solve for x. Now the x is under the radical sign. So we square both sides. So we square, well, first we rewrite this equation on the left side and 0 on the right side. So now we square both sides. So squaring the radical disappears and we're left with 2x plus 3, 0 squared is 0. So now we add or subtract 3 or move the 3 to the right side. We're left with 2x equal to negative 3. Now to find the x, we're going to divide by 2. So it becomes 2x over 2 equals to minus 3 over 2. 2 cancels, x equal to negative 3 over 2. Now we write the ordered pair, negative 3 over 2 comma 0. So that's the x-intercept of the graph of this function. Example 6b, we're going to find the y-intercept of the graph of this y equals to square root of 2x plus 3. So let's write down the equation y is equal to square root of 2x plus 3. We let x equal to 0. So we have y equal to square root of 2 times 0 plus 3. 2 times 0 is 0, so this is gone. We're left with 3. So we're left with square root of 3. So y-intercept is 0, square root of 3. So let's get the equation y equal to square root of 2x plus 3. So step 1, find the x-intercepts. So the x-intercept is negative 3 half, 0, or negative 1.5, 0. Step 2, find y-intercept, which is 0, 3. And now we draw the x-axis, just shown in the figure, and y-axis, and plot the points. Negative 1.5, 0 is here, and 0, 3 is this one. So we join these 2 points to the curve and extend this one, and that's the graph of this equation.